Alright, I'm back again with parameterizing curves. This is going to be a part 2 video now that my part 1 video was rudely interrupted by my phone storage capacity. So here's the same curve that I had drawn in 2 dimensions right when the last video cut out. And I just wanted to point out that vectors are all centered at the origin. It can be very confusing. Because you'll notice that there's no way to shift a vector, right? You can have a vector, you can have a vector 2, 1. All that tells you is go 2 to the right and 1 up. It doesn't tell you where it happens or where its tail is centered. And so we assume that all vectors are at the origin. So any 2, 1 vector, even if it's supposed to be up here, we will analyze it at the origin. And so when we're looking at a parametric vector curve, r of t, which is parameterized x and y as a vector, if, like for example, at t equals 0, when we plug in t equals 0 to these equations, I'll get outputs. And what those outputs represent is the components of the vector at r at time 0. If I plug in time equals 1, then what my answer represents, my r vector at time 1 represents the x and y components at time 1 of a vector that starts at the origin. And so this is our r0 vector, r1 vector, r2, r3, and you could draw infinitely many vectors that would represent all of the analog components of this curve. And what you'd end up with is you just fill in all the space. But it's important to remember that the r vector is always coming from the origin. Don't think about the r vector as pointing tangent to the curve in the direction of the curve, because that's a different vector that we're going to talk about in the next video. It's called the unit tangent vector. And so r is simply the vector that's going to tell us where the point is at what time. So in other words, maybe at time 1.5 I'm somewhere in here, and so the vector, when I plug in 1.5 for x and y, that's going to be spit out is going to have an x component, which is going to go in the x direction, and a y component in the y direction, and the resultant is going to be this vector. Hopefully that was helpful, and I'll see you next video.